Can you believe it? After more than 50 years, humanity is finally heading back to the moon. But listen, this is not just a rerun of what we did in the past. Artemis II is the first crewed mission of a whole new era, one that's all about exploring deep space and pushing our technology and ourselves further than we've ever gone before. So let's dive into what makes this mission so incredibly historic. You know, this quote from NASA's Ernie Wright just hits the nail on the head. It perfectly captures what this is all about. This isn't just about going back to the moon, it's about seeing it, and maybe even our own place in the universe, in a totally new way. All right, so here's what we're going to get into. We'll start with the long-awaited return, then we'll meet the incredible crew making the trip. We're going to compare this new Artemis era to the legendary Apollo missions, break down the critical slingshot maneuver into deep space, and finally, talk about the chance for a brand new, iconic Earthrise moment for our generation. Okay, so first things first, let's really set the scene here. The gap between the last time we sent a crew to the moon and now, well, it's been a long time. A time when exploring deep space with astronauts on board felt more like science fiction than a real plan. Yeah, you heard that right. Over 50 years. Think about that. That's an entire generation, maybe even two, that has never seen a crewed mission go beyond the safety of low Earth orbit. Artemis II is about to change all of that. And this is the key thing to remember. At its heart, Artemis II is a test flight, a very, very ambitious one. Its number one job is to make sure that the Orion spacecraft, its life support, its computers, its navigation, all works perfectly with a human crew inside. They have to prove this ship is ready before we can even think about landing on the moon again, or one day, heading for Mars. So, who are the incredible people strapping in for this historic flight? Well, this crew really represents a whole new era of space exploration. Let's meet them. I mean, just look at the experience here. It is absolutely stacked. You've got Commander Reed Wiseman, who used to be the head of the entire astronaut office. Victor Glover, an incredibly skilled pilot who flew the first operational flight of the SpaceX Dragon. Then there's Christina Koch, who holds the record for the longest a woman has ever been in space, 328 straight days. And making history, Jeremy Hansen from Canada, the very first non-American to ever fly to the moon. This is what a modern global crew looks like. And this is their mission patch. It's not just a cool design, it literally tells the story of their journey. You can see Earth and that bold red line swooping out around the silver moon and back home. It's all right there. And along the edge, their 4 names written into history. So how does this new chapter really stack up against the original? Well, when you put the Apollo missions side by side with Artemis II, the differences are pretty staggering, and they show you just how ambitious this new plan really is. Think about it like this. The Apollo missions kind of snuck up close to the moon, orbiting just about 70 miles high to get a good look at landing spots. Artemis II? It's doing something completely different. It's going to swing way out, thousands of miles past the far side of the moon. This isn't about getting ready to land tomorrow. It's about pushing the Orion capsule into real, true, deep space and seeing the whole moon, poles and all, from a perspective no human has ever witnessed. And to give you a sense of what that'll look like, get this. At their closest point, the entire moon will look like a basketball being held at arm's length. Just try to picture that for a second. Our whole moon filling their window. Wow. But to get to that incredible viewpoint, they have to pull off one of the most powerful and precise moves in all of spaceflight. It's called the translunar injection, or TLI, and it's the moment they truly leave home behind. So what is the TLI? Well, in the simplest terms, it's the pedal to the metal moment. It's one big, powerful engine burn that kicks the spacecraft out of Earth's orbit and literally flings it on a perfect path to the moon. But you don't just hit the gas. Nope, it's a super careful, step-by-step process. First, they'll loop around the Earth a couple of times way up high, checking every single system to make sure everything's perfect. They'll even practice manually flying the Orion capsule near a piece of their old rocket just to prove they can handle it. And only when every single check comes back green do they get the go for that final push. So, what's actually giving them that final mission-critical shove towards the moon? Well, the answer is one of the biggest tests of the entire Artemis II mission. And here's the big deal. On the first uncrewed Artemis mission, the rocket did all the heavy lifting for this part. But this time, for the first time ever with a crew on board, it's the Orion spacecraft's own engine that's going to fire to make that jump to the moon. Proving that this engine works, that it's reliable enough for deep space, that is absolutely essential. It's the test that unlocks future missions not just to the moon, but someday all the way to Mars. So once they're on that path, slingshotting towards the moon, the crew, and really all of us back here on Earth, will be waiting for a moment that could change how we see everything. Check out this map of their flight path. It's this beautiful, elegant figure eight. It's called a free return trajectory, which is a fancy way of saying that after that one big engine burn, gravity does most of the rest of the work. The moon's gravity grabs them, whips them around the far side, and then slings them right back home. It's brilliant. And because of this unique path, they are going to see things no human has ever seen before with their own eyes. We're talking about huge, ancient impact craters like the Orion Basin, and getting a real look at the lunar poles, places we're seriously thinking about exploring in the future. You've all seen that photo, right? The Earthrise picture from Apollo 8. It was more than a picture. It fundamentally shifted our perspective. It showed our world as this fragile, beautiful, blue marble floating in the dark. Artemis II has the chance to give us that profound, unifying moment all over again. You know, that original Earthrise didn't just look pretty. It helped spark the environmental movement. It inspired a generation of scientists, engineers, and dreamers. So as we watch these four explorers go farther than anyone in half a century, the question for us is, what will this new view inspire? Seeing our home, hanging there in the blackness past the moon, what new ideas, what new dreams will that ignite for all of us?